In this video, we will investigate the concept of enantiomers, and using the online drawing program Marvin Sketch, we will model the drawing of a chiral molecule with the correct three-dimensional orientation. We return first to our graphic organizer to see where the concept of enantiomers fits into the more general topic of isomers. Our focus is on the right-hand side branch of this graphic and the two types of stereoisomers. Recall that stereoisomers have the same molecular formula, the same atom connectivity, but a different spatial orientation. In contrast to diastereomers, enantiomers have a very specific definition: a pair of molecules that are non-identical mirror images, that is, non-superposable mirror images. The most common way that this can occur is when the molecule contains one or more chiral centers, usually a chiral carbon. A chiral carbon has 4 different groups attached in a tetrahedral orientation. Note that the tetrahedral orientation about the carbon is clearly represented when 2 bonds are in the plane of the page. One bond is seen as a wedge and the other bond as a dash. A molecule that has an enantiomer is said to be chiral. Therefore, it is appropriate to refer to these as chiral molecules. It is worth noting that diastereomers, in contrast to enantiomers, have a more general definition. Essentially, they are stereoisomers that are not enantiomers. For the purpose of Chem 121 course, however, you need to only work with the EZ type of diastereomer. But for completeness, be advised there are other types of diastereomers. We now return to Marvin Sketch. We will draw the chiral molecule R2-bromopentane. We use the chain draw feature to make a 5-carbon chain. We now select the bond icon to add a wedge and a dash onto carbon number 2. Notice that an adjustment is required to ensure that the 4 bonds are oriented in a tetrahedral fashion around carbon number 2. If you're wanting to change the position or angle of a bond, sometimes pulling up on the bond facilitates this movement. Representing a proper tetrahedral orientation about a chiral carbon is essential to drawing the correct configuration. Now we need to add a bromine and a hydrogen atom to achieve the R configuration. Rather than trying to mentally picture the correct position, one strategy is to simply add each of the atoms and then make a correction if necessary. For instance, it's helpful to place the hydrogen atom on the dash bond, as the hydrogen will have the lowest priority. It will already be in position. A bromine atom is placed on the wedge bond, and the priorities are assigned. With the lowest priority group facing away from us, we count 1, 2, 3 in a counterclockwise fashion. We have drawn the S configuration. We can easily convert to the R configuration by switching any 2 groups on the chiral carbon. We exchange the bromine and the hydrogen atoms to produce the R configuration. At this stage, we want to check that we've drawn the chiral molecule correctly. As before, we do this by clicking the Export button. Then, in the drop-down menu, we select Smiles. We copy the code and return to the tutorial. The code is pasted into the answer box. Checking the answer verifies that our answer is indeed correct. Please run through this example yourself and then try the example on the next slide, where you're asked to draw a different chiral molecule.